So, well, look, conversion. Was there anyone that kind of had any problem understanding about conversions? No, it was all good. All right. So, to go through this, just in case anyone did have any difficulties, label the diagram just with that information. The idea was for the diagram was for me to give you a diagram, show you what it looked like, you put the important points in, and that would help you not only answer this question, but help you to answer the later question, because ideally you would draw your own diagram, okay? Which I didn't see much of actually, so that again, that's a skill. So how can we tell, like a couple of you asked which way round it is, how can you tell which side it needs to be? So it says, for this kick shown that the ball hits the floor approximately 7 meters beyond the posts, okay, it reaches a maximum height of 10. So we can kind of go, well, that's got to be the 10 for a start. It reaches this point having traveled 14.4 meters from the point at which it was kicked. So how do I know? And then it says the posts are at x equals 0. Right, so the posts have to be here. All right. How do I know with which direction the ball is kicked? How do I know? Satya?
Well, because 14.4 is larger than 7, so you know that it has to be on that side.
Yeah. Right. Also, the ball gets to a height and it will come back down before it goes over the post, won't it? Yeah. So, but yeah, it travels 14.4. All right, before it reaches its maximum. So we know this is where it was kicked from. Right. I know that is 14.4 meters, but it doesn't help me with the coordinates yet. But this here is the 7 meters. All right. And because of the symmetry, like I said before, you know. But anyway, this question, label the diagram with that information. That's it, really. That's all you really needed to put on to get that information. But I know for a lot of you, you weren't quite sure what you were doing, where to put stuff, which direction it was, that kind of thing. All right. Does that make sense to everyone though? All right. So then we can do a little bit of analysis. If we put that in, and if we aren't panicking, if we're like just thinking about it clearly, you know, no issues, well, we know that's 14.4. This is also 14.4. So the whole distance here must be 28.8. All right. Which then I can work out where the ball started, what the coordinate was. Yeah. So how do you do that? Yeah, because if you've got the 7 to 0, so this needs to be at negative 21.8. Okay. And then that, I believe, does that determine how far the ball was from the posts when it was placed for the kick? And the answer is 21.8 meters. So you could show that on the diagram, or, you know, I'd be looking for 20.8 minus 7, well, you know. But the answer, it just says determine, so you can just put the answer. That's fine. All right. I'm not going to do this one straight away for a reason. All right. So let's just go straight now to use the equation to determine if the kick is successful. That means it clears the crossbar. Justify your answer. So the equation that I've been given is that one. So you mentioned that previously. So what is it? 0.048. And then it's x plus 7.4 squared plus 10. Okay. So you did mention before that if you didn't have the equation, it was difficult to do the rest. So this should be, that's why I gave it to you, so you can carry on. But what's important and was interesting to me is the number of people that didn't quite know what to do. So this equation is the same equation if you change it to a different form. So a couple of people expanded this and rewrote it in a different way, but this is the same equation, right? It's just in vertex form, but you can use it in the same way. So if it clears the bar, we're basically saying, if there's the crossbar, where is the ball? Is it up there? Is it down there? All right. What do I know about those points? Well, I know it's when x equals 0. So I just put it straight in here. I don't need to do anything else. So what is the y value? 0.048, 0 plus 7, that squared, plus 10. Okay. And when you do that, what answer do you get? Those people go, right. 7.38, if it's round, I don't know. Meters, okay. Not quite enough, but good. I think a lot of you learnt from last time, we have to justify our answer and we say, yes, it's successful because 7.38 is greater than 3, or it clears by 4.38 meters, or whatever. You got to have that final statement. But I saw a lot of that, which was good. All right. But I did see people making life difficult for themselves by redoing the equation in a different form, or and it wasn't asked for. All right. Going to go back to that other bit in a bit, but let's move on. Unless any of you've got any questions about that. No? If a try is scored next to the touchline, explain the impact. So this was your chance to really get lots of things to be said. Anything that's relevant gains you credit and marks in criterion D. Because criterion D, if you look at it, says identify most or identify all of the relevant elements. So if you only do one thing, you're basically only identifying some. So you can see where the difference is. So let's just come up with it now, and I'm sure some of you won't have thought of it. But even if you've not played the game or tried doing that, I'm sure you could have a good idea. So give me some impacts. Jack?
The kick is not perpendicular to the post.
So
it's at an angle and more distance.
So a lot of you put that, yeah? The kick has to go further. That was the common one. And a lot of you kind of stopped at that point. Anything else we could say? Aidan?
I also said that it would make it harder to convert because the angle of the post would be different.
Yeah. So a couple of people mentioned the angle. So it's actually harder to, the posts actually, if you look at the posts from an angle, they actually become narrower, don't they? So but it's like a smaller target. So yeah, mentioning that. Anything else? No? Depending if you're left or right footed, is it harder or easier, or I don't know, something you could mention? Basically those were the two things though. The distance one, but also the fact that you are not directly in front of the posts. It's at an angle, it's got to go further, it's harder to get to. Anything you can write that might be relevant, yeah? The only thing that's not relevant in this case, wind, air resistance, blah, I haven't given you any information about any of that. So don't rely on that when you're talking about sports stuff, all right? Although that could be an impact. So if the wind is blowing directly down the pitch, right, it would make it, but it's equally because you're at an angle and the ball is still being blown away. It was the same for both, but maybe it's more, but we don't know. We don't have that information, right? So that's the kind of question you've got your opportunity to just write anything that might be relevant. Okay. Assuming the ball is placed. So this is kind of what, we're starting to do diagrams now. So here's the posts, okay? This is where the ball landed before, all right? Let's say this is where the ball was kicked before, all right? But now it's going to be 10 meters to the side, all right? So this is the path looked on above how it went before. this is the path it's going to go now. All right. This is the 10 meters to the side. So if we label a diagram, 10 meters, this distance we've already decided is 28.8. I even told you, which if I wanted to make it nasty, I wouldn't have told you use Pythagoras' theorem. All right. But you get 10 squared plus 28.8 squared, square rooted, and I think you get 30.48, something like that, which is approximately 31 meters. All right, because that's what, almost 31. Okay, so assuming that the ball lands at the same place, we've got to show this. All right, but I'm going to go back to this first one now, and let's look at how we find this equation. Okay, how can you really clearly show it? Well, I did like some people saying that, well, vertex form is y equals a computer x minus h plus k, where h is the x coordinate and k is the y coordinate. So just putting that in, right? And the vertex is then at, well, where is it? So really, I should be seeing somewhere some calculations of that. So where is the vertex? Well, I've been given that the y value is 10, but what about the x? And how do I show that though? Yeah, but how do I show it?
So the vertex is in the middle of the curve, so you can just take the 14.4 and subtract it from 7 and get the middle.
Yeah. So sorry, that's not 20. That should be 21.8. So we've got the 28.8. If we divide that by 2, we get the 14.4. But you already knew that. So you either do the 7 subtract 14.4, right, which you get negative 7.4, or you do the negative 21.8 and you add 14.4 and you get negative 7.4. Either way, we should be trying to see, I mean, if I can see that on your diagram, fine, right? But we kind of like to see that rather than just, because I know I said really all you're needing to do is show me this value, but we kind of need to, I've not given you what the vertex is, so it means you need to show me how you calculated it. All right. So then we can say, well, that is negative 7.4. So then we can start with the y equals a times x. Now you could put minus, but don't worry about that. 7.4 squared plus 10. I was looking for that. And then we're going to use a coordinate. What coordinate do we need to use? Not the vertex. Either of the other ones. So we could use 7, 0. Again, put it in here. So we've got 0 equals a times 7 plus 7.4 squared plus 10. So 0 is a times 14.4 squared plus 10. This was interesting. The number of you that forgot how to rearrange. Right? What's 14.4 squared, by the way, for those that forgot it?
207.36.
A plus 10. Okay. A couple of you, I saw it in the test, and I saw it afterwards, you took the 10 from here. And the only reason you did that is not because you think that's correct, but the numbers were big and funny. All right, you've got decimals now, so that obviously changes everything I've ever been told. All right, so we don't do that. We have to subtract the 10. All right, and then you divide, yeah? So negative 10 divided by 207.36. And what do you get? Negative 0.0. Okay, so I've shown that's the case. Any questions on that point? Is that clear about how you can get all the credit for that sort of question? Right. Okay, let's go back then to this one then. So assuming the ball lands. Now this was where I kind of thought, well, now it might make more sense that I've got to explain these, because if all you did was use the form before and just work out this number, you're going to do the same at this point. So we kind of have to work out those. So what I've done, I think, is I'm drawing a new curve. All right? Drawing a new curve. That curve, all right, is for this line here. All right, so if I now ignore this one even existed, if I just look at this line from the side rather from the top, I will have this curve, yeah? It will have done that. Make sense? So you kind of have to redo things, but with that curve. So what do I know? Well, it lands at the same place. Yeah. It travels 31 meters. Now, if you use the 30.48, right, but we can use the 31. Well, that means that we do 7 subtract 31, means that this point here has to be negative 24. Right. Yeah.
This really bothers me because since it's at an angle, we aren't 7 away,
Yeah.
and it should actually be slightly longer,
Yeah.
and so it wouldn't be negative 24 on the
No,
other side.
you're right. But if I'd done that, it would have made it a whole
Yeah.
lot harder,
But
wouldn't
it
it?
was good to have the example
Yes.
to help us.
Yeah,
and
if
we
I'd
figured
have
it out.
said just figure it out, it would have been horrible. So having this, you know,
We can try and figure out your reasoning behind this.
yeah. All right. So yes, no, he's very right. But again, that could be something to write about here, right? It's the get out of jail free card, is the justify your answer. Because you could have said, I don't know if the ball's going to be successful because the curve doesn't actually model the situation very well. You know, that's a perfectly good answer. All right. Anyway, so we've got these numbers. So once you've worked that out, I don't need you to then explain that therefore this is, you know, once you've worked that out, I'm happy if you said, so therefore it's A times the X, these are the roots, so X plus 24 and the X minus 7 bits there, all right? And then we just find A, again, same as we did before, using which coordinate? The vertex, which we've got to work out. So the same height is 10. The middle bit is now negative 8.5, yeah. All right, so I've got using X equals negative 8.5, Y equals 10, put that in. So 10 equals 8 times negative 8.5 plus 24. Again, no need to change it. Negative 8 minus 7. And once you rearrange all that, I'm not going to bother, you end up with A equals negative 0.041 rounded, yeah? Okay, so you've shown that. But that little bit extra, you know, I needed to see that you knew where the 24 came from, even if it is a little bit flawed as an example, yeah? All right, hence or otherwise. Why have I put hence or otherwise?
Because you might have used vertex form.
Yeah. So when it says hence or otherwise, it's giving you a clue that actually what you just did will help you, but you're not limited to that. There is other options. All right. Now you have just worked out that the vertex is negative 0.85, 10. Therefore, vertex form is x plus 8.5 squared plus 10 with the a. Okay. Now, is a negative 0.41?
Yes.
How do we know that?
I will know.
Okay. Is there any way that I could show that that is the case?
Test it.
Oh,
Yeah, just test it with a coordinate again. I could work it out. If you're happy though, I'm happy. If you know that this value of a is the same as the other one, that's the hence bit, isn't it? All right. So we just put that back in. So we've got y equals negative 0.041. X plus 8.5 squared plus, again, no need to expand this and simplify and do all that. Just no need for any of that hard stuff that a couple of you tried to do. So this assessment could have been a lot easier. How much I've written hardly anything for that question. Some of you needed extra paper at that stage. Okay, any questions on that? Is that all right? Right, again, determine if the kick would not be successful or not, or what do you do?
Let x at 0.
Put x as 0 again. Yeah. What is y? Which equation do I use? Either one. You've got two options now. Use either one. There's no special working out. I just put y equals negative 0.041 and it's x plus 8.5 plus 10. Chuck that in and you're done. All right. Or negative 0.041 and it was x was it plus 24 and x minus 7. Put 0 into that and work it out. You should get the same answer. All right. If you don't get the same answer, something's gone wrong. But I will have done it wrong because I gave you the equation. Maybe not the vertex. Anyway, it makes sense without having to work it out. So what's your answer to that? Successful or not? Yeah, according to the functions, it would be successful for the same reason it's greater than the 3 meters. You could have that discussion though about the limitations of the function in the first place. Be a good place to have it. All right, add to your criterion D. Right, this one, not many people got this as much as I thought it was going to get actually. Explain and justify the degree of accuracy. So some people got it. What would you say? Jack? Go on.
Since I chose 10 meters because it was any less accurate would create too much differences, which could make the difference between the ball hitting the actual bar or going over it.
Yeah.
And millimeters would not actually be measurable on the pitch.
Yeah. Does that make sense? So to what accuracy is centimeters? Hundreds, yeah? 2 decimal places. So you would say the degree of accuracy that you have used, hopefully you stuck to the 2 decimal places. If you said at some point I left it to more than that, someone did mention that if you didn't use more than that, your value for A might be a little bit different, which is fine. But really for a task like this, what Jack said is it's spot on, isn't it? You know, we need to be as accurate as we can be to make sure that those values, because when you've got a quadratic, I don't know whether you have looked into this or not. Let me see whether, if I put in Desmos. So one of the things I was thinking of asking you to do was come up with your own problem of this sense, but it's actually quite tricky. All right, if I put in y equals 0.041 and I put x plus 24 and x minus 7, okay, here's the curve that you end up with. You'll notice, look, that that's not actually quite at 10. I had to be as close as I can. Now what happens if we change this, let's say I put 48 instead. Now that's one, I've just changed that 7 1/1000ths. All right, and look, it's different at the maximum height. Right. So the accuracy there for that A value is actually quite important, right? And this is the thing. This is where when I created this, I kind of had to go, well, how much accuracy can I even put here? So if I put another one, you know, I could add more in and make it exactly, but how are you going to get those numbers, you know, especially if they don't quite work out, right, in other areas. So that's the accuracy thing. You've got to be careful because this A value in this real, I mean, look what happens if I try and make it easy. Just so you know, right, I can't make it easy. If I put a 2 in there, for instance, to try and make it easy, look what happens to the kick.
It's a really big player.
Yeah, 480 meters at the highest point if I just put a number of like 2 in there, right? So then you try and think, well, you know, what about just, let's keep it 0.9. No, you know, what's that? I mean, that's a lot lower, but it's still tall, isn't it? It's still a big one. So then you're like, okay, right, well, let's make it easy, 0.5. Still 120 meters. All right. So this is why I was saying it's actually not the easiest question to make up a question and keep it easy numbers. And that's because it's a criterion D. It has to be applicable in real life, right? I could have rewritten the question and said this is a projectile being fired in space or something, but we wanted to make it realistic. So do you appreciate why the accuracy for this number is important? All right. But equally, in terms of does it cross the posts or not? Well, if we've got 0.041, right, so it crosses the posts, that point there, 0.688, it's definitely above the post. Well, how far can we go if I did right. Right, we knock off over a meter and a half lower by being 100th difference. And if I was 0, you know, suddenly only just making it by changing 100th at a time. So that's why Jacques' point was also good there. All right. So yes, in terms of answering the question that we were working on, all right, to really explain and justify. Some of you explained that it was 2 decimal places or that kind of thing, but you didn't really justify why that would be appropriate in this sense. Some of you wrote loads without saying a lot as well. So we get out of, I don't want an essay type of thing. Yeah. All right. Any questions on any of that? How